Today we're going to be dividing polynomials using synthetic division. So we've already divided polynomials using polynomial long division, and I'm going to show you this very quick method to divide polynomials that are written in the form x minus a. Okay, just like this x plus 2, so there is not a coefficient other than 1 for this binomial. So the first thing that you need to make sure when you are dividing polynomials using synthetic division, we want to make sure the dividend is written in standard form. Remember, that's highest exponent to lowest exponent. So as you can see, this first polynomial right here is written in standard form. 3x cubed plus 13x squared plus 2x minus 24. You also want to make sure that the binomial divisor, that's this one that I highlighted in yellow, is linear. That needs to be linear, and it needs to be written x minus a, or just a polynomial that, how you can think about it, is x plus 2. You might have x minus 4, you might have x plus 3. What you can't have is 3x plus 2 or 3x minus 4. You'll have to use polynomial long division for that. So how do we use synthetic division? What I'm going to do is I draw this little like half of a rectangle right here. I draw it just like that. And then I take all of the coefficients, 3, 13, 2, and negative 24, and I write them right here. 3, 13, 2, and negative 24. And then I take this x plus 2, and then what would x need to be? Like if I were to solve that, x plus 2 equals 0, x would need to be negative 2. That's what I'm going to put right there, okay? So how do you think about it? Take the opposite of what that x plus 2, you're going to put a negative 2, right? So that's what I'm going to do. So how does this synthetic division work? I'm going to show you this example, and then we'll go and we'll work through several other examples together. The first thing I'm going to do is I'm going to bring down this 3, and then I'm going to take 3 and I multiply it by negative 2. I get negative 6, and I write it right here. And then polynomial long division, you subtract. Synthetic division, you add. 13 plus negative 6 is 7. And then I do it again. 7 times negative 2 is negative 14. And then we're going to add. 2 plus negative 14 is negative 12. Negative 12 times negative 2. I write it over here. 24. And I add. And I get 0 as my remainder. So this right here is the remainder. And then here's my constant, here's my x term, there's my x squared. So 3x squared plus 7x minus 12. So this little portion right here, use zeros in the place of coefficients that have missing terms. That's important, and we'll talk about that in the examples to come. So let's work through our first example right here. X cubed plus 2x squared minus 17x plus 18 divided by x minus 2. So what I'm going to first do is, I know this polynomial is written in standard form. I take that dividend and I write the coefficients just like this. 1, 2, negative 17, positive 18, x minus 2. I put 2 right here. Okay, the solution of that factor would be 2, right? So I put that right here. And then I'm going to draw this line right here, and I'm going to switch colors. Okay, so the first thing I'm going to do is bring this 1 down, and then I multiply 1 times 2, and I get 2. And then I add. I get 4. 4 times 2, I get 8. And then I add. Negative 17 plus 8 is negative 9. Negative 9 times 2 is negative 18. And then I add, and I get 0 as my remainder. So 0 being my remainder, my solution is x cubed plus 2x squared minus 17x plus 18 divided by x minus 2 is, there's x squared, there's my x term, there's my constant, x squared plus 4x minus 9 is my answer. So my quotient. How can you check your work? You take that trinomial, multiply it by this binomial, and you should get that answer right there. Let's move on to example number 2. Example number 2. I have this polynomial divided by this linear binomial. So I'm going to draw my little rectangle right here. I'm going to erase this so it doesn't confuse you. That polynomial is written in standard form. And what I want you to see is I have 2x to the fourth plus 8x cubed, but notice that I don't have an x squared term. I'm going to put a 0 in place of that x squared term. So make sure you have a placeholder. So there is no x squared term. So make sure you have a placeholder there, okay? So if I had like, if it jumped from 2x to the fourth minus 4, something like that, or plus 5, something like that, you would need a placeholder for x cubed, for x squared, for x. Okay, so we need a placeholder for x squared, and then we have plus x, so that's a positive 1, and then we have a constant of 4, so there's a 4. My divisor is x plus 4, so I'm going to put negative 4 out here. All right, so what do? Let's start. I bring down this first term, that's 2. 2 times negative 4 is negative 8, and I add. I get 0. 0 times negative 4 is 0, and I add. I get 0. 0 times negative 4 is 0, and I add. I get 1. 1 times negative 4 is negative 4, and I add. I get 0 as my remainder. So my solution is, here's my constant, x term, x squared, x cubed. 2x cubed plus 1. There's my answer. So again, if you want to write here, this is your remainder. Whoop, I didn't write that very pretty. 2x cubed plus 1, how can you check your work? 2x cubed plus 1 times x plus 4 will give you this polynomial right here. Let's move on to our last and final example in today's notes. I just wanted to, this example has it written like this because all this is a division problem, right? It's this polynomial divided by this polynomial. And because this right here is a linear binomial, we can use synthetic division with with a leading coefficient of 1, right? So what can I do? I take this polynomial up top, draw this, and I put my coefficients, right, from starting with the highest exponent down. So we have a 3, we have a 21, and notice I do not have an x cubed term, so what do I put there? I put a placeholder. Do I have an x squared term? I don't, so what am I going to put there? A 0. Right here, make sure there are no x or x squared terms. Put a little note there. There are no x or x squared terms. So let's make sure we have those placeholders in there. And then we have a negative 5 and a negative 35. And then we're dividing by x plus 7. So we're going to put a negative 7 right there. Right? So it's the solution to that factor. And let's draw our line down here. And then let's get started with this process. The process is the same. I'm going to bring this 3 down. 3 times negative 7 is negative 21. And I add. I get 0. 0 times negative 7 is 0, and I add. I get 0. 0 times negative 7 is 0, and I add. I get 0. 0 times negative 7 is 0, and I add, and I get negative 5. Negative 5 times negative 7 is positive 35, and I add. I get 0 as my remainder. So my solution in this case, there's my constant, x term, x squared, or x term, x squared, x cubed, x to the fourth. So 3x to the fourth minus 5 is my answer. How do you check your work? 3x to the fourth minus 5 times x plus 7 will give you this polynomial right here. And that concludes your notes over synthetic division. I hope it was helpful.